Welcome back to Maths with Mrs. J. We've been talking about probability and we've started to introduce the idea of independent events and non-independent events. Independent events are ones where they have no bearing on the probability of each other. So certainly if you're doing completely different actions, you're rolling a die and tossing a coin, clearly what happens on the die isn't going to affect what happens on the coin. All right, so if you're doing completely different things, they're going to be independent. Or if you're doing the same thing where it has no bearing on the next time, that will also be independent. Things like drawing balls from a bag and then replacing them before drawing the next one will be independent. If something has any bearing on the probability of the other trial or the other event, then that is conditional probability. Now, the formula looks a bit confusing, but we've already actually been working these out. If things are independent, then you simply multiply their individual probabilities. If they're not independent, then what you have to do is multiply the first probability by the probability of the second one if you know what the first one has happened. We already did that in our previous video. We talked about, okay, well, the first one was red, so now given that information, what's the probability that the second one will be blue? That kind of thing. Let's do some examples. It's actually a lot easier than that makes it sound. Let's have a look at our first example. So we draw a card at random from a pack of cards, usual pack of cards, and a die is rolled. Find the probability that a diamond and an even number. So probability of diamond and even. Well, they're completely different things, so there's no reason why they're not going to be independent. So it's just going to be the probability of getting a diamond from a pack times probability of getting an even number on a die. What you get from the pack of cards has nothing to do with what's going to happen on the die, okay? Probability of getting a diamond, well, we've got 13 diamonds out of our 52 cards, or you could just remember that that's a quarter because it's one out of the 4 suits. Even, well, 3 out of your 6 are even. So it's a quarter times a half, which is an eighth. So the probability of getting a diamond and an even number will be 1/8. Now, if we're drawing 2 cards simultaneously, then what the first card is, okay, it's kind of like drawing without replacement, will affect the second card's chances. So here we do need to think about conditional probability. So both diamonds, well, the probability that the first one is a diamond, again, simultaneously work it out as drawing without replacement. So that's why I'm referring to the first one and the second one. Probability-wise, simultaneously is the same as drawing one out and not putting it back before you take the second one. So the probability that the first one is a diamond, well, you've got 13 diamonds out of your 52 cards. Right, that's your PA. Now, this is our PB given A. Now we're saying, okay, we've taken one out and it was a diamond. So how many diamonds do I have left? Well, I've got 12 diamonds left. And how many cards do I have left? Well, I have 51 cards. So we get a quarter times 12 on 51. We can cancel down. And what do we get? 1 on 17, I think. Yes. Now, do you see how that's different? We're not just doing probability diamond times probability diamond. where this bit here, we are assuming that we've already got a diamond. And we're saying how many diamonds are left and how many cards are left. We could even extend that if we wanted to and say we draw 3 cards simultaneously. What's the probability that they're all diamonds? Well, the probability that the first one is 13 on 52. Probability that the second one is, you've only got 12 diamonds left out of 51 cards. Probability that the third one is a diamond, you've only got 11 diamonds left now out of your 50. That sort of idea, that is conditional probability. Now, the probability that they're both the same suit, well, we could split that up into saying, well, they're both diamonds plus probability both hearts plus probability both clubs, sorry about my drawing, plus probability both spades. All right. Now, we've already worked out the probability that they're both diamonds, and there's no logical reason why these wouldn't actually all be the same. So we're just going to get 4 on 17.